Today I'm going to look at logic gates and Karnaugh maps. Let's start off with some simple logic gates. Now we have three main gates that we're going to look at. The top one is an AND gate. It looks like a capital D for the word AND. And if you have a 1 for A and a 1 for B, then you get a 1 coming out of the end. Everything else you get a 0. Next one is an OR gate. If you have a 1 going into A or a 1 going into B, you have 1 coming out. And actually, in this case, if you have 1 in A and a 1 in B, it also gives you 1 going out as well. The last one is a NOT gate. If you have a 1 going in, you have a 0 coming out, and if you have a 0 going in, you have a 1 coming out. And these are three main gates that we use on our course. We're going to look at Karnaugh maps. Now, first of all, a Karnaugh map is a diagram which contains ones and zeros, and in this case for inputs A, B, C and D, but it could just be for A and B, or it could be for A, B and C. We only ever deal with either 2 inputs, 3 inputs, or in this case 4 inputs. Now when you have your inputs and your outputs to make a table, there are certain rules you have to follow. First of all, we want to group our groups together in as large a group as possible. So here, instead of having 4 groups of 1 or 2 groups of 2, we have 1 group of 4, the biggest we possibly can. They can only be in multiples of 16, 8, 4, 2 and 1. And they can only contain 1s. We can't put our grouping around any zeros that are there. They can be horizontal and they can be vertical. They can't be diagonal. And then finally, if we need to, we can wrap around just like a Pac-Man from one to the other. So instead of having 2 groups of 1, that last group is actually a group of 2, but it wraps off the right hand side and appears back on the left hand side. So let's see about making a Karnaugh map from 2 inputs from a logic diagram. So we've got ourselves a logic diagram, and we've got A and B going in. I've put in C, D and E as midpoints, and we've got Q as our final output. We're going to have our little logic table so you can figure out what Q is going to be. And we're going to have a little Karnaugh map which is just going to show A and B. First of all, we look at C. Now C is just the NOT of A. So if you look, A was 0, 0, 1, 1 as we read down column A. So this is 1, 1, 0, 0. Next we look at D. Now D is an OR gate from A and B. So if you look at A and B, for 0, 0 we get nothing, but for 0, 1, 1, 0 and 1, 1 we get 1s, because it's an OR gate. Next we look at E. Now E is when you get C and D and you put it into an AND gate. If you look at our C and D, we only have a 1 for C and a 1 for D on one of our rows, so that gives us our output E. And then our final gate, Q, is the end of an OR gate. So we look at D and E and we're doing an OR gate. So we're looking for either a 1 in D or a 1 in E or a 1 in both. So that actually gives us this as our answer for Q. Now what we do now is we transfer this across into our Karnaugh map. So if you look at the first column, it's where A is 0 and B is 0. So that's the top left hand corner. Q gives us a 0. There we go. We then move down. Now when A is 0 and B is 1, that is here, A is 0, B is 1, we put a 1 in there. The next one is A is 1, B is 0, which is here, A is 1, B is 0, we put a 1 in there. And then finally, when A is 1 and B is 1, which is this square here, we put a 1 in there. Now we have our Karnaugh map, but we're going to look at groupings. Now we want the biggest group possible. Now we can't do a group of 4 because that would involve 0. We don't really want to use 1s because we want the biggest group possible, so we're going to have to do groups of 2. So we can have 2 groups of 2. And as you can see, yes, they can overlap, that's absolutely fine. Now most people are fairly happy getting to this point, but the difficult bit is how do we represent those groups? Well, what we do is we look at each bubble and we try and see what value is consistent in that bubble and ignore the values that change. So our answer is actually A or B. because the group going from top to bottom is A is 1 in both of those, but B changes. So A is 1 is the consistent thing. So that bubble is known as A equals 1, or just as A. The bubble going across is B is 1, and if you notice, A changes from 0 to 1. So therefore B is a consistent thing, and B is consistently 1. So either B equals 1 or just B. So the answer is A or B, one bubble or the other bubble. The first bubble is A, second bubble is B. Now then, if we wanted to have a 3 input system, exactly the same again. We have a little system, we put in some midway points, we bring up our table, which is obviously bigger this time because we've got 3 inputs, we've got more combinations, and we're going to have a 3-way table for our Karnaugh map as well. First of all, let's work out D. Now D is A and B through an AND gate. So if we look down the A and B column, AND will give us a 1 if we have A and B, which is only the bottom 2 entries. E is an OR gate from B and C. So we look down B and C and find where we've got a 1 for either B or C, or both, then that gives us a 1 as an output. So there's only 2 cases where it doesn't give us an output, because B and C are both 0 on those 2. Then we look at F. Now F is an AND gate for B and C. So again, we look at B and C, but we're looking for where we've got both of them. And we put a 1 where we get both of them. And on this one, there are only 2 occurrences. We then look at G. G is an AND gate from E and F. If we look down E and F, again, there are only 2 occurrences where we have 1 for E and 1 for F. Then finally we look at Q. Q is an OR gate, but this is D and G, so be careful as you read your columns. Where D and G, we want to have at least one of those, and there are 3 occurrences where D is 1 or G is 1, or possibly both. Now we've got our answer Q, we're going to transfer this back across into our Karnaugh map. So if we start with A is 0, B is 0, C is 0, that is the top left hand corner. So we put a 0 in there. We then move to the next one, which is A is 0, B is 0, C is 1. And that moves downwards, that's the one underneath it. If you look there, we put a 0 in there as well. The next one is A is 0, B is 1, C is 0, which is this one here. Put a 0 in there. And our next one is A is 0, B is 1, C is 1, which is this square here. We put a 1 in there. Now you've got to be careful here, because A is 1, B is 0, C is 0 is actually this one here. And we put a 0 in there. And then A is 1, B is 0, C is 1 is actually this one. And we put a 0 in there as well. We've only got 2 more to go. And this is A is 1, B is 1, C is 0, which is this one here. Got to make sure you put them in the right squares. We put a 1 in there. And then the last one is A is 1, B is 1, C is 1, which is our last square. And we put a 1 in there. Again, we need to look at groupings. Largest possible group we can. No diagonals. We've got 3 1s, therefore again it's going to be 2 blocks overlapping in, 2 blocks of 2. Now we've got to figure out what these bubbles mean. Now if you take the bubble across the bottom, C is always 1, and if you look at A and B, B is always 1. So 1 across the bottom, B is always 1 and C is always 1. If you look at the bubble going downwards, A is 1 and B is 1, but C changes, so it's just A is 1 and B is 1. Now we don't just say A is 1 and B is 1, we say A and B, and then the second bubble is B and C. And it's either one bubble or the other bubble. Remember, the V shape means or, and the mountain shape means and. And that's our answer. Now, you could do a 4 inputs from a logic diagram, but it's quite difficult. But sometimes you actually just get given the logic algebra. So here we have an expression. B and D, or A and B and D, or not B and not D. Now if you've got this odd expression, all we're doing is we're just doing the inverse of what we did before. The last step before was to find our bubbles and get an algebra expression. Here we're getting the algebra expression and make it into one of the bubbles. Our first bubble is B and D. Now, if we're trying to figure out b and d, we need to look at where b is 1 and d is 1. b is 1 and d is 1 are the four centre squares. Doesn't matter what c is doing, doesn't matter what a is doing, we just want where b is 1 and d is 1. Our next expression is a is 1, b is 1 and d is 1. Now if we look at the square where a is 1, b is 1 and d is 1, there is only one square, and that's our bottom right hand corner, and actually we've already coloured that one in anyway, so that is actually an expression we don't really need. The next one is not b and not d, so we're looking for where b is 0 and d is 0. b is 0 and d is 0 are the four corner sections. Now as we've done all of our expression, then obviously the other squares are just going to contain zeros. That's fine. And again, we need to group them together in the largest groups possible. Now it's obvious that yes, there's a nice big block of 4 in the middle, but these 4 are on the outside. Remember, we can Pac-Man them. So we could do 2 groups of 2, we could do 4 groups of 1, but the best solution is 1 group of 4, but they Pac-Man around left and right hand, top and bottom. Now if you think about those expressions, they're actually expressions we had at the beginning. If you think about the centre section, it was b and d. That's how we created it in our diagram, so actually that's what we represent at the end. b is 1 and d is 1. And if you think about the 4 on the corner were from b is 0 and d is 0, so not b and not d. Again, that's our expression again. So you can see how our original expression has been simplified to create our end expression, because the middle component, a and b and d, if you remember, that was like a doubles value. We didn't need it. So that gives us our final expression. Hopefully that made sense. If you've got any problems or any questions, just leave me a comment and let me know.